Okay? Let's do some more math. Let's do intermediate algebra. Martin Gay, 4th edition, section 2.4. And let's do problems 2 to 44 odd. Okay, the first one says x such that x is greater than 5. This is the set notation. This is the set of all x such that x is greater than 5. And they want us to graph this on a number line. So what we have is a number line, which 0, 1, 2, 3, 4, 5, -1, -2, -3, -4, -5. Okay, and this is going to be x greater than 5. So what does that look like on a number line? Well, it's greater than 5, so we put the curve on it. And then it's anything greater than that, so I'm just going to use that arrow notation. I think that's the way they do it. Yep, that's how they do it. They use the curved line when it's greater than. And you use a solid bracket if it's also greater than or equal to. We can just keep the line there. Okay, now this next one is going to be x such that x is less than -0.2. Wow, 0.2. Okay. Well, -0.2 is around here. We're going to have the curved line, and it's going to be less than, so that goes to the left. Less than goes to the left. Okay, on the number line. Okay, I'll just use the green. Number 6 is x such that -7 is greater than or equal to x. Now, if -7 is less than, that means x is greater than or equal to -7. Okay, and I'm sorry, -7 is greater than, so I'm sorry, this should be less than, so less than looks like that. So you can move something from one side of the equation to the other by turning the less than sign into a greater than sign. Okay, I see that my top one was not quite high enough. I'm going to move that up a teeny bit. Okay, that would be fine, I guess. Okay. Okay, x less than -7. Well, I guess my number line, I got to make sure it goes further. I didn't get it all the way to -7, -6, -7, -8. Okay. My number line has to be big enough. It's going to be less than -7, less than or equal to. Oh, I'm sorry, less than or equal to. So, because it can include 7, I use a different notation. I use that bracket. Okay. Number 6. Okay, now let's go to number 8. This one says -5 is less than or equal to x, which is less than or equal to -1. So this means that it's going to be between -1 and -5, including the two ends. So that's the interval. This is called a closed interval. It's an open interval if it doesn't include the endpoint. Obviously, I'm putting this higher than the number line, so I don't have to keep redrawing the number line. Okay, the next one says -3 greater than x, which is greater than or equal to -7. Now, you can see they put the smaller number on the right. It's kind of backwards. I would want to redraw this to have the -7 over here. this says x is greater than -7. So -7 is less than or equal to x, which is equal to less than -3. And that's going to help to do this. So it's less than or equal to -7, but then it's less than -3, not equal to. So it's open on the end of -3. X is less than -3, but greater than -7, and that puts it in this interval. Okay. Inequalities. Graph the solution set. Write it in interval notation. Okay. X plus 2 is less than or equal to -1. Okay. Now, we can, on the inequality, we can do a lot of the same things that we did on inequality, which means we can move this to the other side and it becomes a negative. So this is going to be, I'll move it down underneath now. X is less than or equal to -1 minus 2, which is x is less than or equal to -3. So that's going to be a closed interval on 3, but it's going to extend all the way less than -3. Less than or equal to. So it's got a closed bracket on one end. Okay, I'll try to work underneath now. Okay, here's one. 11x is less than 10x plus 5. So what we're going to do is we're going to move this to the other side where it's going to be subtracted. 11x minus 10x is just x, so we end up with x is less than 5. So it's less than 5, but not equal to 5. So it's going to look like that. Less than 5. Okay, number 16 says 7x minus 1 is greater than or equal to 6x minus 1. Okay, so let's get the x on one side and the 1 on the other side. So we end up with x is greater than or equal to 0, because that becomes a plus 1. 7x minus 6x. X is greater than or equal to 0, so that means it's going to be like this. It's going to include 0, and it's going to be everything greater than 0. Okay, that was 16. Now 18 says 5/6 of x is greater than or equal to 5. So we're going to multiply both sides by 6/5. So x is going to be greater than the 6. In other words, the 6 is going to go to the top, the 5 is going to go to the bottom. It's greater than 30 divided by 5. That's x is greater than or equal to 6. X is greater than or equal to 6. And I ran into the same problem here. My number line didn't go out long enough initially. 6, 7, 8. Let's try that. Greater than or equal to 6. Okay? What's that? Good? That's number 18. Number 20 says 4x is greater than -11.2, or x is greater than -11.2 divided by 4. So you can do that on a calculator. 10 divided by 4 is 2.5. 1.2 divided by 4 is 0.3, so it's -2.8. X is greater than negative 2.8. So greater than means it's going to go to the right. Negative 2.8 is approximately right there. It's not greater than or equal to. It's just greater than. So it's an open interval. It's an open on the left side there. That's number 20. Okay. Number 22. Negative 4x is greater than or equal to 8. Now we're going to divide both sides by negative 4. We're going to bring the negative 4. Now here's the trick. This is the first time that we've had to bring a negative over to one side. And here's where it's a little bit tricky. When you multiply both sides by negative, you actually have to change. So this is going to come out to be x less than or equal to 8 over negative 4, which is x less than or equal to negative 2. Now let's see if this makes sense. Okay, we're going to do a check on this. Negative 2 less than or equal to. Okay. Now, for example, if x is equal to negative 3, negative 4 times negative 3 is positive 12, and positive 12 is greater than or equal to 8. So that's included in the set. So you can see we went in the correct direction. When x is equal to negative 2, that's included. Okay? The rule is, when it's an equal sign, you can multiply both sides by any number you want, but when it's an inequality, when you multiply both sides by a negative, you have to flip the inequality to the other type. And that's just one of the rules of manipulating that you have to learn for inequalities. Okay, that was 22. Now let's go to 24. 8 minus 5x is less than or equal to 23. So we're going to move the 8 to this side, then we're going to divide by the negative 5, and we're going to end up with x greater than or equal to, because we were dividing by a negative 5, 23 minus 8, that's 15. On the bottom is negative 5, so x is greater than or equal to negative 3. Okay? Greater than or equal to negative 3, so that's going to be a bracket, and it's going to go to the right. And that's 24. So 26. 20 plus x less than 6x minus 15. Okay, we're going to move this over where it's going to become negative 5x. We're going to move this over where it becomes negative 20. Negative 5x less than negative 15, and negative 20 is negative 35. Or in other words, x. Now greater than, we're going to move the negative 5 over to the other side, put it on the bottom, but we have to change the negative sign to the plus sign. X greater than 7. It's going to look like this. Oh, I'm sorry. It's going to be the parentheses, because that's open on that side. And you could put in a number here if you wanted to test it out. You could put in 8 just to make sure that it was part of this set. 28 is less than 48 minus 15. 48 minus 15 is 23. Oh. Let's check that out. Eight. 28. 28. 48 minus 15. Oh, 48 minus 15, that's 30. 33. So yeah, that's correct. 33. Okay, good. I thought I might have got that wrong, but that was okay. Everything was fine. I was just checking by putting in 8 to see if it was part of the solution. Okay, the next one, 6. Looks like my pen is a little bit running out. Okay, 6. 2 minus 3x greater than or equal to 12. Okay, first we'll divide by the 6. Get the 6 over to the other side. Subtract off the 2. Divide by the negative 3. And we're going to end up with x is less than or equal to, and it's going to be 12 divided by the 6. That gives us 2. Minus the 2. Minus 2, that gives us 0. And when we divide by the negative 3, we still get 0. So this is saying x is less than or equal to 0. Okay? And let's just check, plug in negative 1 as an example. That'll be negative 1. Negative 3 times negative 1 is 3. 2 plus 3 is 5. 6 times 5, which is 30, is greater than 12, which is true. So that's okay. Now, if we put in 0, for example, then it just says 12 is greater than or equal to 12. And that because it's equal, that tells you it's on the boundary. So everything there turned out okay. And I went on that. I did that one kind of fast because I did all 3 steps all in one line. 5 x plus 4 less than or equal to 4 2x plus 3. So we multiply things out to get 5x plus 20 less than or equal to 8x plus 12. Now we can start moving things. Move this one and move that one. We got negative 3x less than or equal to negative 8. 12 minus 20, x greater than or equal to 8 divided by 3. As we divide, we bring the negative 3 to the other side, flip the less than to plus, less than to greater than, 2 negative signs cancel out. 8/3, that would be 2 2/3. So we'll get a closed bracket, closed interval on one end. It goes to infinity on the other end. And that was number 30. Okay, number 32 reads 1 minus 2x divided by 3 plus 3x plus 7 divided by 7 greater than 1. So first we want to get rid of these things on the bottom. So what we're going to do is we're going to multiply both sides by 21. Because that's going to, because 3 times 7 is 21, and we multiply both sides by 21, it'll get rid of these numbers in the bottom. And we'll have 7 minus 2x plus 9x plus 21 is greater than 21. So when I multiply this by 21, the 3 cancels the 3 in the 21, and ending up with a 7. And 21 here is 3 times 7. The 7's get canceled. I end up multiplying this by 3. I'm sorry, this should be 7 times 3 is 21. There. Yeah. I caught that mistake there. I wrote that down as a 2. That was a mistake. I don't know why I did that. I didn't write down the 1. Okay. Now, this is going to be 7x, just putting like terms together, plus 28 is greater than 21. Get the 28 over to the other side. 7x is greater than minus 7. X is greater than negative 1. Okay? X is greater than negative 1. Looks like I just went slightly off the scale there. Okay. x is greater than negative 1. That was the last line. So, negative 1, open interval, greater than. Okay, that was number 32. Should put that number line up a little bit higher. Okay, now, number 34 reads negative 2. Maybe it's time to do it in purple. Negative 2 times 4x plus 2 greater than negative 5. Now we have a square bracket, 1 plus 2, x minus 1, square bracket, but that bracket's no different than a parentheses. This is just a little bit messy, but the idea is to multiply, get all the like terms together. So this side is negative 8x minus 4 is greater than negative 5 minus 10 x minus 1. Okay? And now I'll just turn this 10x minus 1 into 10x minus 10. But because of this negative, that negative, we're going to get plus 10. So this is going to be minus 10x plus 10. Okay? And now we'll move the 10x over to this side, move the 4 over to this side. That 10 comes over as positive 10, so we'll have 2x greater than. Now on this side, we're going to have a plus 10 and a negative 5. That's plus 5. And then we're going to, the negative 4 comes over as positive 4, so it all comes over as 9. And therefore, x is going to be greater than 9 over 2, which is 4.5. So 4.5, that's going to look like that. Okay, and that's number 34. Now let's go to number 36. Okay. Write the solution set using interval notation. X minus 9 less than negative 12. Okay? So all we do is move over the 9 to the other side, and we get x is less than negative 12 plus 9, which is negative 3. Now they say write this in interval notation, and they also said to do that in the other one, but all I did was graph it. Now the interval notation on this one is going to be, it's less than, so the interval notation is the parentheses. And we're going to include infinity. First, let's graph it just to get you an idea. It's less than negative 3, so it's going to look like this. Okay? So what we can do is we'll make the parentheses, and we'll put negative 3 on one side end of it, and with the other one we'll put in negative infinity. Okay? And that represents this interval. The curved part of the interval corresponds exactly to that line. Now, on this negative infinity, it's kind of arbitrary whether or not you put an open parentheses or the square bracket there, because it's infinity. So I noticed in the book they're putting in the parentheses, but I don't really think it makes any difference there. Okay. That was number 36. Now we'll go to 38. Negative x greater than negative 2. Now we just multiply both sides by negative 1. This is x is less than positive 2. So that's going to be open paren, and it's going to go like this. And the interval notation is going to read negative infinity, comma, 2. Close parentheses. That's 38. Now let's go to 40. Negative 6, x, less than or equal to 4.2. We have to divide both sides by negative 6, so we're going to change this to greater than or equal to. And 4.2 divided by negative 6. Well, 6 times 7 is 42. So when we divide 4.2 times 6, we're going to get 0.7. And it's going to be a negative because we're dividing by a negative number now. So it's going to be negative 0.7. Greater than or equal to negative 0.7. Negative 0.7 is somewhere around here. It's going to be greater than or equal to, so we get the square bracket. We're going to go like this. So in the interval notation, that's going to look like square bracket, negative 0.7. And then we're going to put that infinity in. I'm going to use the close parentheses. That is number 40. Now we're going to go to 42, which I think is the last one on this homework assignment. I think we're only going to go up to 42. Or we could go up to 44. 42. 3/4 minus 2/3 greater than or equal to x over 6. Okay. Now, we can add these fractions a couple different ways, but I think if we multiply both sides by 12, that's actually going to get rid of all these numbers in the bottom, see? So if we multiply this by 12, 4, and then 4 is going to cancel on the bottom. We're going to have to put a 3 on the top, and that's going to be 9. We multiply this fraction by 12. 3 cancel that, we'll get minus 8. 12 here is going to be 2x. So all this is reading is that basically 1 is greater than or equal to 2x, or 2x is less than or equal to 1, or x is less than or equal to a half. Okay? X is less than or equal to a half, so that's going to be square bracket. It's going to go this way. On the interval notation, that's going to be negative infinity, comma, 1/2 of the square bracket. Okay, that's number 42. We'll go up to 44 in this exercise. And then we'll call it. Now 44, negative 6x plus 2 less than negative 3 times x plus 4. Okay, so we're going to group equal terms. Negative 6x plus 2 less than negative 3x minus 12. Now we're going to move this to the other side, where it's going to become negative 3x. I'm going to move this to this side, where it's going to be a negative 2, so that's going to be negative 14. We're going to basically move this negative 3 down here, changing this to a greater than sign. X is greater than 14 over 3. And 14 over 3 is 4 2/3. Somewhere around here, x is greater than that. So it's going to look like this. And the interval notation is going to read 14/3. Nothing wrong with that. And then go into infinity. And it's going to be greater than. Okay? So that's section 2.4. And that's all for tonight.